Carol has 1,000 feet of fencing to fence in a rectangular horse corral. Find a function that models the area A of the corral in terms of the width x of the corral. So first of all, I'm going to draw a picture of the rectangular horse corral. And two of the sides will correspond to the width and two to the length of the corral. We know that for a rectangle, the perimeter is width plus length plus width plus length, or 2 times the length plus 2 times the width. Since we're told the perimeter is 1,000 feet, I can substitute 1,000 for P equals 2 times L plus, and we're told to use X for the width, so 2X. This actually will allow us to write L in terms of X. We'll get 2L equals 1,000 minus 2X, or L equals 500 minus X. So now what we were really asked to do is to write the area in terms of X. And so we start with our formula for the area of a rectangle, length times width. But we can substitute the 500 minus X for the L and the X for the W. We can rewrite this as minus X squared plus 500X. So A is a function of X. So then we're asked to find the dimensions that maximize the area. Since the formula for area is a quadratic, we can find the point where the vertex of the parabola occurs. And so we have A equals -1, B equals 500, and C equals 0. So the maximum value will occur when X equals H, where H is equal to the opposite of B over 2A. Here we are assuming that the vertex of the parabola, which is the graph of the area, has coordinates H and K. So computing H, we get the opposite of 500 divided by 2 times -1, and that's going to give us positive 250. So the maximum area occurs when the X is equal to 250 feet. Now, so the dimensions that will create the maximum area are 4W in this case equals 250 feet. But then what should the length be? Now we have to go back to the fact that our length is 500 minus x. So the length equals 500 minus 250, which is 250 feet. So the dimensions are 250 feet by 250 feet. So the dimensions that maximize the area actually are the same dimensions that would make the rectangle into a square.